In this series of videos, we are exploring the world of AI by using PowerBASIC to connect to the Ollama Windows server and run queries against the Open AI GPT OSS 120 billion parameter large language model. So since our large language model is running on this computer, how would we access it if we were using another computer on the same network? And if we could, can it be set up to handle requests from multiple computers? That's what we're going to look at today. Since the Ollama application which is running on our computer can only process one request at a time, we need to find some way of queuing up these requests if they come from multiple computers. Additionally, we need some way for these multiple computers and applications to talk to our computer which holds the Ollama server. In order to do this, we're going to use the Internet Protocol. The Internet Protocol is designed for transmitting lots of data called datagrams from one computer to another. However, the way the Internet Protocol works is that it takes the data image to send and breaks it up into a number of discrete data packets. These packets can be transmitted across the network, and they don't necessarily have to take the same route. Therefore, when they arrive on the destination computer, they can be out of sequence. And the Internet Protocol itself makes no attempt to reassemble this sequence. That would be the job of the receiving application. However, there is light at the end of the tunnel. You can use the User Datagram Protocol. Using UDP saves you having to worry about fragmented data. By the time the packets have arrived at your application, they have been reassembled into the correct order. There's no guarantee that the UDP message will arrive at the far end. However, the packets themselves will not be fragmented, and this UDP is what we're going to be using today. So here is the new application. We're going to write this application in the console compiler. This will effectively be our server application, running on the computer that holds the Ollama server. This application, once started, will sit, wait, and listen for incoming requests to a specific port number. So we're going to set up some global variables and a constant to allow us to handle this. We're setting up 3 global variables, one called thisServer, which is a string variable to hold the name of the computer that's running this application. Secondly, we're storing the IP address of this computer. And finally, we're going to create a handle for the UDP connection. This will be our connection to the UDP clients at the far end. Finally, we're creating a port number. This is the port number on which our UDP server will communicate with the clients. We have covered in previous videos how to set up client-server applications using UDP, but we'll cover the basics in this video. So in our PB main function, we're going to set up a local variable called request. This will contain the request that is going to be processed. Next, we will populate our global variable for the name of the server, and we will use a little function to populate that server name. This very basic function is pulling back one of the environment variables, the one called computer name, which, as the name suggests, will return the name of the computer this application is running on. Next, we're setting the caption of our console window, in this case, UDP Ollama server. In normal running, there will be no one to watch this console application. But we're using the console here just so we can see what's happening for the purposes of debugging. So now we can get into the work to create our UDP channel. And I'm going to be making use of some inbuilt commands from PowerBASIC. First, we will use the host address command to extract from the computer we are running on the host IP address. Next, we want to open up the channel for UDP. So we will use the free file command just like we would with any other file to populate our global variable. Next, we want to open the UDP port. Again, PowerBASIC comes to the rescue as it has a UDP open port command, which takes a parameter of our port number which we had previously stored in a constant. And just like opening a file, we have an as command to say what's the file handle number. And we can set the timeout in milliseconds. If this generates any kind of error, then it will beep and exit this function immediately, which would then terminate the application. Next, for the purposes of debug, we're sending a message to our console to say listening for broadcasts to that particular IP address. And we're using here a macro, m.ip, which turns the numeric IP address into something that is human readable. This macro is one we have used before, and it takes the numeric value of the IP address, turns it into the standard 4-element IP address. So now that we've got this far, we now want to listen for incoming requests. So we're going to be using a do loop here. And here is our do loop. We initially set the request variable to blank. We will be calling a new function called processRequests, which will populate this variable. If the request variable contains the string exit, then we have been requested to close down our server application. At that point, we will exit the loop and close down the Open UDP channel. Otherwise, we will sleep for 100 milliseconds and repeat. There is the close command for the Open UDP channel, just like you're closing a file. It's followed by a sleep of 5 seconds, and then we end the application. So let's now go and create this process request function. So this is where we start listening to the UDP port. We've created 5 variables in here, a buffer to contain any data we get in on the UDP channel, a data variable to hold data extracted from that, the IP address of the machine sending the request, and the port number to reply to. Our final variable is target server. This is to ensure that the request coming in from the port is indeed for this computer. This would allow us to set up several of these servers to handle multiple requests at some point in the future. Next, we need to use a UDP receive command to receive data coming in. This is just like the file command, as it uses the channel number we previously set up in our global variable for the UDP port. And then we're using the from command to populate the IP address variable, which contains the IP address of the sending computer. Then followed by the port number, and the data will be in the buffer variable. So the buffer variable contains all the information we need. We're going to pull that data out by using the parse command. Firstly, we're going to pull out the target server, which is the first element in this buffer string, which is pipe delimited. So in this case, if the target server does not equal the name of this computer, then it's not intended for us. And we could, if we wished, send back a message to say not accepted. And we can then exit the function from that point. If we get this far, then the request is for this machine. So we can pick up the request type by again using the parse command to extract the second element of the string. There will be a number of different types of request. As we've already seen, there will be an exit request to shut down the server, so we're going to use a select case statement to handle each of these types of request. One of them is going to be a query request, where we want the server to run a query on the Ollama server. So here are the two options. The first option is query. We'll send a message back to the requester to say that the request has been accepted. And then we'll go to run a query function on the Ollama server. We'll come back and create that in a moment. If we are exiting, then we will send a message back to the requester to say that we are indeed exiting the server. Let's now go and create the run a query function. So here is the skeleton of our new function run the query. taking its single parameter, which is the buffer variable. What we created so far was enough to get communication between the client and our server. For the moment, we're just going to push the data received out to the console, just so we can see what's coming in. Now we're going to go back and look for changes we need to make to the client application itself. So here is our PowerBASIC Windows application. The application at the moment presents a dialog to the user, allowing them to type in a query to be sent to the Ollama server. Currently, the application assumes that the Ollama server is running on the same computer. So we will need to make some changes to allow this application to communicate with the remote server. In order to do this, we're going to create a constant to allow us to programmatically compile the application to use a remote server or to run locally. This will give us flexibility in our testing and debugging. Firstly, I'm going to set up some new constants. We're using a run-on-server constant. If this is declared, then we're going to be communicating with the remote server. If not declared, then we will run locally. The target server we will be using is Mini001. In the future, we'll probably put this information into a configuration file, but for the moment we'll just set it up in the code. And we have a channel number for our UDP channel and a port number. I've also created the query accepted constant, which will be used to confirm that data has been received. So we already have a user-defined type for our Ollama data. We're going to add two more pieces of information to this construct, one to hold the target server name and one to hold the task we wish to do. So now we've added those two elements to the user-defined type, we'll make similar changes in the logic in the event handler and the callback function when the user clicks on the Run Query button. Now here is a section of code that runs when the user clicks the Run Query button. Further down in that function, we have the population of the user-defined type. So we're going to add on the two extra elements to this. First of all, the target server, which we are picking up using the setup constant at the beginning of the application, and the second is the task, which in this case is hard-coded as query. And slightly below that, we have the line of code where we create the thread function. This is a function which is used to actually run the query on the server while the main dialog waits for a response. So we're going to do a bit of conditional compilation here, as I'm going to create a brand new thread function to handle calling the remote server. And there is our conditional compilation. We're testing if the constant has been defined to run in the server. If that's the case, then we're going to create a brand new thread function called call Ollama server. Otherwise, we'll be calling the existing thread function. So this means we can now go ahead and create this new threaded function without having to change any of the functionality in the existing function. So we'll put this new function just before the original one. And here is our conditional compilation, with the new function name call Ollama server. Now I'm going to make this function slightly different to the previous one. We are, however, picking up the target server name and the task, which is query. Next we will use the host address command to pick up this machine's IP address and also the address of the target server. We can then add a new piece of code to open up a UDP channel for transmission, just as we did in this server code. The buffer variable will contain the data we wish to send, which will consist initially of the target server name and the query. Now the query, at the moment, only contains the word query. We will add on the rest of the data in a moment. Our remit for today is to establish basic communications with our Ollama server. So having populated the buffer variable, we can now use the send command to attempt to send our string buffer to this port number. And we will wait to get a response from the server using UDP receive. What is populated in this string buffer is what comes back from the server. We're not at the moment testing this, but we will be in the future. The idea is that what comes back from the server is a queue number. Let's say, for example, our server is sitting waiting on request commands from 5 different computers. The first computer sends a request query. It's then number 1 in the queue. The second computer also sends a request query. It's now number 2 in the queue. By the time computer number 3 sends its request, the first request may have been processed, in which case this will be passed back to the first computer. The second computer will be informed it's now number 1 in the queue, and this third computer will now be number 2 in the queue. So this process will allow for all of these computers to be kept up to date as regards their place in the processing queue. Since the large language models on the internet do not have infinite capacity, they must be using some kind of queuing mechanism also. So we will take the same approach. So assuming you get a response back from the server, we will then close down the open channel and exit the function. We're returning to the calling function with the value query accepted. So now that we have the infrastructure in place for the communication to our server, let's test it to see if it works. Before we run the test, there is one last change we need to make. The existing code in the Windows client tests if the Ollama server is running locally before displaying the query dialog. For the moment, I'm going to comment out those lines of code, and we'll add that functionality to contact the remote server in the next video. So here are our 2 applications, the query dialog on the left and the remote window to our server on the right, showing that it's listening for requests. So if we type in a request and click the Run Query button, you can see that the server receives the query. So in summary, what we've achieved today is to create a new console application that listens on a UDP channel for incoming requests and acknowledges when each has been received. We have amended our client application to either compile as standalone or client server, dependent on a constant in the code. This proof of concept means we can, in the next video, put our queuing mechanism in place to allow our local large language model to be accessible from any computer on the local network. But that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.